Hello everyone. The title of our paper is Real-Time Automated Face Recognition System for Online Examinee Verification, and the authors of this research are Milind Rane, Amruta Amune, Mukund Kulkarni, Nikhil Prathamesh, Mandar Paras and Saurabh. Moving on to the introduction, in today's era, everything is revolving around the internet and moving towards implementing in the online techniques. Exams are usually conducted in online modes via various online platforms. This increases chances of forgery and cheating in examination, and it becomes a challenging task to identify the original candidate or is any other person has acquired the place of that particular candidate. This problem can be solved by using online exam proctoring system where face recognition will be used, and for that we need a continuous monitoring process as well as to control all the students during the test. Thus, we have proposed a system which integrates with various technologies such as computer vision, biometric recognition, and deep learning. This system will precisely identify if the person attending the exam is same throughout the examination or not. This solution is financially feasible, and proper technical measures that are implemented can result in accurate identification of the candidate. Moving further to literature survey, we researched on this domain and found out that the facial recognition and drawing face features may be done in varieties of ways. These are few papers that have implemented facial recognition in applicational use with the help of different algorithms and methods, such as the application of AdaBoost algorithm implemented along with ANN classifier, the Bayesian face subregion algorithm, the HOG frontal face detector of dlib library, the face recognition method of OpenCV library, the most famous Har cascade classifier technique, and the Egen face method for face detection and recognition. And many more technologies are there that can be used for this domain of the project. Research gaps. Facial recognition and drawing face features may be done in variety of ways. The deep learning models are basically used to develop the most efficient methods. If we try to develop the model from basics, we will require a lot of processing power, experience, and data. So here comes the MediaPipe libraries that excels at simplifying difficult jobs for us. In this work, we utilize MediaPipe to create a model technique for face detection and sketching facial landmarks. And for the classification of the faces, the Inception design has been proven to deliver excellent performance at a reasonable computational cost. More than a million pictures, including the ImageNet dataset, were given to train the convolutional neural network Inception ResNet v2. And this FaceNet model performed very well in low lighting condition, and the results were more precise and accurate as compared to the other techniques. Moving on to the problem statement, the statement of our work is the proposed model should be able to identify the fake candidates accurately, where face recognition will be used by creating a way to handle the problem of detecting individuals in live stream with a range of complicated lights and backgrounds, as well as facial recognition in variety of forms, brightness, and reflections. The point of the work is to design a biometric model that is to be implemented as a candidate authentication and identity verification proctoring method for the exams. And the novelty of this work is the introduction of optimized Inception ResNet v2 for an ideal online testing system where the system can detect faces of the candidates and generate a report of automated monitoring of the candidates. Next is the important functionality or the objective of the project. Our proposed system will act as a real-time proctoring system with an enhanced version that eliminates the need of human proctoring for the duration of the test. Our system provides an remote candidate login system for online exams. Also, for the admins, detecting identity frauds and analyzing cheat behaviors will be easier. Also, the admins will be able to monitor the proctoring tracks if no face detected, many face detected if the user is authenticated, estimated cheat status, and its log analysis. So these were the objectives of a project. Moving on, proposed system. In the proposed work, two modules are being used for anticipated web-based online proctoring system. Firstly, the facial recognition proctor module, and secondly, the online exam management module. In our project, we have focused to tackle this issue using pre-trained Google's MediaPipe face detection and face mesh algorithm for face detection and pre-trained Keras Inception ResNet v2 CNN for face classification and deployed it in a web app using Django framework. So this is the workflow diagram of the face recognition proctor model. This includes the implementation of pre-trained inception recent V2 convolutional neural network algorithm of the Keras library from TensorFlow. Also, the face detection and face landmarks estimation is done using Google's MediaPipe library, face detection and face mesh respectively. The AI has three vision-based capabilities which are combined using to make them work together. That is, detect faces, detect facial landmarks, and verify the faces. The profile pic which examinee uploads is stored in database, and this ResNet model will be given input, and the proctoring will start monitoring that particular examinee. During proctoring, the webcam will be accessible, and the frames will be continuously evaluated to see whether there is no frame in the face, if there are numerous faces in the frame, or if the student face from image saved matches the current frame face or not. This is the system diagram for examinee level in online exam management model. Here the candidate will have to register using his or her respective image and username and password, and then log in into the system, and that candidate will be able to give the exam of the respective subject, which is in the form of MCQ pattern. While giving the exam, webcam access will be taken and video will be sent to face recognition model in the live stream window. The face recognition model is rendered on the web page into Django web app using OpenCV video stream library and connected to SQLite3 database. This CV2 model will display whether the candidate ID is matching with the image ID or not, and if any type of cheating is suspected, it is displayed. After ending the exam, cheat status report is sent to database along with the marks calculated. It will generate a whole exam session estimated cheat status report using Matplotlib PyPlot data visualization library and store the status report in the database. This is the admin level system diagram of online exam management model. The admin will have the authority and functionality of managing the student, add subjects, add questions, etc. Admin will have the privilege that he can view the marks of students along with their respective cheat reports. Moving further to the results of the project, this is the web page from the examiner's side. Here the candidate will have to upload a pic that is to be given as testing input. The ResNet model proctor successfully detected and verified the user respective to the user's image while the user is giving the exam. If the user is authenticated, it will show user as verified. Using the ID of one person, if another person is detected, the face recognition successfully detected impersonated face and set the status of the face as unknown and warns cheating suspected. The model was successful in detecting multiple faces in frame along with the user as verified or unknown, and if so, it will display the message cheating suspected. From the admin panel, the admin can see the students, their respective exam attempts, their marks, date and time of exam, and mainly the cheat summary report generated by Proctor model. This is the cheat summary report, which is generated by Pipelet library, and the parameters of our model like no face detected, multiple face detected, user authentication, and estimated cheat status are displayed precisely. When the parameters are satisfied with the result is generated 1 as a high, and if not, then 0 as low. Estimated cheat status can be used by admin to take specific action against the candidate that had given the exam. Moving to the future scope, this project will be further extended by adding more modules of Proctor like the eyeball movement tracking, the mouth detection that is lips open or closed, the speech recognition if the person is talking or not via audio, head pose estimation, face spoofing detection if the person is still image or is a live human, other person and phone detection in the frame, browser monitoring that is monitoring of other tabs and windows opened while giving the exam. Real-time alerts will be given to candidates if the cheating is suspected. Moving towards the conclusion, our study provided a facial recognition based candidate verification method that leverages face recognition technology for identity verification in examinations. Using the FaceNet models and facial traits, we constructed a strong real-time face identification system from a single picture. The suggested method not only identifies the face but also locates and recognizes a candidate based on their crucial facial traits. These characteristics are critical for face recognition to work well. These are the references we have referred for our research. Thank you.